So, Simon,
So,
would you like to just, start us off by just, going into a little bit about your background and how you got involved?
yeah, sure. So I'm not sure. I can see a few of you joined. This is my first time on this platform, so it's great and slightly strange to be here. My name's Simon Steele. I'm based at the Seti Institute in Mountain View, California. It's about an hour south of San Francisco, in the heart of Silicon Valley. The SETI Institute, as the name suggests, is the search for extraterrestrial intelligence. It's an research center that's been around now for just over 40 years. It was founded in 1984 by Jill Tarter, amongst others. Carl Sagan was also involved, with the purpose of searching for intelligent alien life in the universe. Originally part of a NASA program, but federal funding for the search for intelligent aliens ended quite a while ago, and most of our funding for that comes now from private donations. But I joined the Institute about 6 years ago in 2019. I'm an astronomer by trade. My interests are galaxies, which, although we do live in a galaxy, as do all aliens, galaxy research really has nothing to do with aliens. But I've always been fascinated with the idea of alien life. Of course, I grew up on Star Trek and Doctor Who, as we all probably did, in one way or another. So I've always been fascinated by the idea of life in the universe and aliens and science fiction. And it's very interesting to see how actual science addresses a question that is, a little bit out there, but less out there than it used to be. It's now becoming much more mainstream.
Yes, it is. I think it's much more popular. Um, and Yeah, so I wonder if you could talk a little bit about, the interstellar object that you were actually just talking about, if you don't mind. I think that'd be great.
Yes. Yeah, what's interesting is, of course, the sun and the solar system is just one planetary system in our galaxy. Our galaxy has about 300 billion stars, and pretty much every one of those stars has its own planetary system with comets and asteroids and so on. So we've got about 1 trillion or so planets out there. But everything's very far apart in the galaxy. The galaxy is very, very big. And so what's very exciting is a little bit a while ago was the first detection of an object from interstellar space. That is, an object that's come from outside of our solar system and works its way into our solar system and then flown out the other side. That first was observed in 2017. It was an object called Oumuamua, which is a Hawaiian word for visitor, I think. And this was quite amazing because we'd never discovered anything else from interstellar space traveling through our solar system. And of course, it's got everyone very excited. Anyone who's enjoyed science fiction knows that, the aliens are bound to come into the solar system at some point, for good or ill. But it was a natural rock, not very big, about 30 meters across, and just happened to be passing through the solar system. It turns out there's lots of stuff probably out there in interstellar space that's been knocked out for some reason from another planetary system as just passing through. Then there was another one in 2019. This was a comet that came from another star system. Of course, our solar system has lots of comets that occasionally appear in the inner solar system with their beautiful long tails. But this one actually came from another star. And now the third one has just come in, called I3 Atlas. I stands for interstellar. 3 is the third object, and Atlas is the name of the telescope that discovered it. And I have to tell you that what Atlas stands for, because it is really science fiction meets science facts. Atlas stands for the Asteroid Terrestrial Impact Last Alert System.
Oh, wow.
which is a telescope in Hawaii that's designed to pick up things as the last ditch attempt before it hits us. Of course, it detects things that don't hit us, but it tracks these objects, and it discovered this object coming into our solar system incredibly fast, 140,000 miles an hour. It's started off just as a speck of light, and it's been observed now by many telescopes, and it turns out it's probably a comet. And the best way to think of a comet is a large dirty snowball. It's basically some rock, sand, ice, and as it approaches the sun, it heats up, and all the ice, mainly water, boils off and leaves that lovely long tail. And so this is probably a comet, but you don't know. And being a research center looking for aliens, the first thing we do is we point our radio telescopes at these objects. And one of our astronomers was on the call today as we did it. This is what we call Seti Live. We do these weekly conversations with scientists. You can watch them on YouTube. And pointing a radio telescope at this object to see if it was transmitting anything. Because if it was a spacecraft, it may well be transmitting something. And it's not. We probably knew it wasn't going to, but you have to check these things. And there's going to be lots of observations of this object as it shoots through our solar system and then travels out the other side and carries on back into interstellar space.
That's so fascinating. Yeah, I suppose it gives you a chance, just for a brief period to see something that's come from, so far away. It's really different to anything in our solar system.
Yes. We can figure out what it's made of, probably very similar to the material in our solar system. But there's a thought that it's incredibly old. It could be billions of years older than our sun even, because it possibly comes from a part of the galaxy where the oldest generations of stars, very, very old stars, reside. And that's pretty cool in a way, because if you think about life on Earth, we are the product of about 4 billion years of evolution, starting from sort of primordial slime to creatures that can travel between the planets. It took about 4 billion years. So some of these stars are, 5, 6, 7 billion years old. So they could potentially have a sort of a 2 billion year start on us as far as life on their planets.
Oh, wow.
And that's interesting to think about, what sort of place this object came from. It could have come from a planetary system with incredibly advanced life and civilization. We don't know. So it's, there's lots of speculation.
Yeah, that's really interesting. And if anybody has any questions, you can put it in the chat. This is like my second time on Spaces, so I'm just getting used to the system.
Okay, so you just somebody who's been on this twice is an expert compared to somebody who's been on it once. I think that's yeah.
Exactly. But I also wanted to talk to you a bit about the amazing movie Contact, because
Yeah. Mm-hmm. Yeah, now the book Contact, written by Carl Sagan. I have a copy on my desk here that my dad got me. It's a first edition, which is really cool. So I'm very, very proud of this. Came out 40 years ago this year, and written by Carl Sagan. And Carl Sagan, of course, I'm sure everybody has heard of his name. He was an astronomer who was fascinated by alien life, but also he worked on planetary missions. He worked on the first Mars landers and so on, and wrote this book about first contact with aliens. And it's very interesting because if you read it, it's a fascinating read. About the first half of the book is very, very accurate to how SETI works.
Mm-hmm.
SETI is a science. The second half, of course, post-discovery, is a discussion of how we think we would react to the discovery of life elsewhere. Of course, we don't know how that will manifest itself. Now, they made a great movie with Jodie Foster. The main character in his book, Ellie Arroway, was based on a real astronomer, Jill Tarter, who was the founder of the SETI Institute. And a lot of the characters in the movie, there's a blind astronomer in the movie, for those of you who've seen it, and which is true. There was a blind staff astronomer who worked with Jill Tarter in Seti work back in the 70s and 80s. So a lot of that is actually true. There's a lot of politics in it, of course, and a little bit of religion thrown in to discuss the ideas. But it's a great film. I find Matthew McConaughey rather irritating. I should say that's the only downside. The other people like him. I don't know. But it's interesting that the sets, and my apologies to those who haven't seen the film. You should run out and see it. It's fabulous. It's set at a couple of real radio telescope facilities, which is fascinating. There's one called the Very Large Array. That's a wonderfully sort of artistic name for it's a very large, and it is an array. And an array is a collection of multiple radio telescopes. And that's in New Mexico. And that is a very, very impressive opening scene where the discovery is made. And the other place is in Puerto Rico, where they had the largest radio telescope in the world. So big it couldn't actually move. It actually was built in a collapsed limestone cave that gives you a nice sort of natural bowl in the middle of the rainforest. And that was used as a set for the movie, and that was a real radio telescope that was used for SETI research, and so that was very interesting. They used that as a site. Now I keep saying it was because unfortunately it was destroyed in a hurricane about 3 years ago. The Caribbean being susceptible to big hurricanes, and it actually critically damaged the structure of the telescope. And there's a lot of talk about rebuilding it, but it's expensive to rebuild something like that.
Oh gosh.
But those are wonderful sort of scenes of very impressive places that are actually real radio telescope facilities.
Yeah, I think Emily, you went, didn't you, to visit one?
I didn't actually get to see it. I had a really interesting experience in Puerto Rico, and I realized I was just a mile from that site.
Yeah. Yes.
It seems like lots of signals come through. I'm curious, Simon, we watch a lot of Hollywood movies and we kind of guess how you guys actually interpret the data or what kind of maybe tools you use. I'm sort of curious if you could talk about, I know you mentioned radar. What are some of the tools that you use to gauge whether we're being communicated with or whether there's life out there?
Yes. Of course, the big problem is we have no idea how an alien will communicate, and that is a problem. And so you have to make some sort of guesses, educated guesses basically around the natural world. And radio astronomy is, we think, a natural way to detect signals from other star systems. Now, as I said, the universe is very, very big, and so the chances of actually physically interacting with an alien species, despite what they do in Hollywood, is incredibly low. So what you're looking at is looking for a signature of technology, what we call technosignature, which is a transmission, whether it's aimed at us or we just happen to be along the line of sight. And radio technology is probably the best way of doing that, because you can transmit a long way through the galaxy using radio waves, whereas other types of radio waves, and radio is a type of light. It's just a long wavelength light that we can't actually see. So radio waves exist in nature. And in fact, hydrogen, which is the most common element in the universe, emits radio waves when it gets jiggled around in space. And it emits at a very, very specific wavelength of light. That seems to be a universal beacon. And so what's been done a lot in the past is listening, and I'll use the word listen, but these are light waves, but we use the term listen for radio waves that are similar in the natural emission of the universe, because that seems to be a good place to look in the sky. And radio waves have been, studied now back to the 1960s. And we've had a few false alarms, some of which are famous. But at the moment, no technology, nothing has been detected that isn't human-made. I mean, radio telescopes detect signs of intelligence every day, but it's generally somebody's cell phone or a plane flying over or a Starlink satellite. These are all signals that have to be sort of swept out of the way to look for potential signals from aliens. So radio waves are the best way of detecting a signal. There's a lot of work now in visible light communication. It's very interesting that one of NASA's most recent missions is called the Psyche mission, is actually now communicating with Earth using a laser rather than using radio waves. And so laser transmission communication is another way that we are checking, and we have telescopes that can pick up potential laser transmission from alien civilizations. So these are the two main ways where you actually sort of you try and detect a signal. There are other interesting ways of doing it as well, but those are the two main ones.
That's really fascinating. I mean, it must be just such a, you're searching so much. Can you talk a little bit about the, you guys, like your processing power, like how does it work in terms of that and monitoring?
Yeah, so a typical radio telescope is nice thing about radio telescopes is you can operate them during the day as well, because you don't need a dark sky. You just have to keep away from looking at the sun, which produces a lot of radio waves and will burn your circuits out. So these telescopes are generating huge quantities of data. One description I've heard is that a telescope like the VLA in New Mexico is basically downloading the equivalent of data of every season of Games of Thrones, streaming every second into their detectors.
Oh, interesting.
So the big problem is, there's lots of problems with that. The one problem is that's too much data to store, and I'll come back to that in a second. And so the other problem is, how do you analyze that data? How do you look for strange shapes in that signal? And the only way it can be done these days is using machine learning, artificial intelligence, which will be able to analyze the data coming in real time to try and detect something that looks odd. And so you have to define what you mean by odd, something that's not obviously a satellite downlink, something that's obviously not a cell phone transmission, something that's obviously not a lightning storm, which also produces radio waves. And then it identifies these anomalies and will then alert the astronomer that something is very, very different. The big problem, as I said, is you cannot store this much there. You do not have enough hard drives to store all this information. And so you have to throw most of it out very, very quickly. And that's a problem, because you don't know what you're looking for. And so you don't know if you're throwing stuff out that may well be the stuff that you're looking for. And this is a big dilemma.
Definitely. Simon, my brother's here from the UK, and he had a question for you.
Sure.
Can you hear me, Drew?
Hey guys, yeah, long time nerds, first time listener. I was just wondering, Simon, have you heard of any sort of like developments with sort of the quantum entanglement communications? Is that something that has started making sort of like a bit of headway? I know they've started messing around with it with quantum computers, but is that something that's hit the astronomical world, should we say?
Not so much in observational astronomy. and it's not my area of expertise, unfortunately. So the quantum computing is very, very promising in terms of course, analyzing signals and doing it very, very quickly. And that's something that's going to have to be done, with this large quantity of data that's coming in. Quantum entanglement, looking at ways to, sort of communicate very, very quickly over long distances is a great idea, and it's, scientific fact. But there's not yet an ability to see a sort of practical application of this in astronomy.
Makes sense. And when you mentioned AI, what is that? You're using that to process the data, or it's going to be upcoming?
No, currently it is being used to process the data and doing first pass over the data, because there's too much data for humans to analyze. And the good thing about machine learning is it's very good to look at patterns. It's pattern recognition, really. Another way that it's used, and the way that's used at the Seti Institute, is to detect planets around other stars, what are called exoplanets. So, as I said, we think sort of pretty much every star in the galaxy, in the universe, has at least one planet going around it. There are a few exceptions. The stars are doing weird stuff that couldn't have planets, but on the whole, every single star, when you look up in the night sky, has at least one or two planets going around it. But it's very difficult to detect those. You have billions of stars, and planets are incredibly faint. It's very, very difficult to see a planet compared to a star. Stars are very, very bright, and planets are very, very dim. And so the way that you discover a planet is when that planet passes between us and its parent star, the planet blocks a little bit of light from the star. And so the star gets tiny, tiny and imperceptibly dimmer because of the little planet passing in front of it. And so this is happening, more and more now as we are able to analyze, the light from hundreds or thousands of planets every night, stars every night, to actually look at the brightness variation and seek out this very, very subtle change in the brightness of a star that will give you a hint that there's actually a planet going around it. And so these identifications are now made with machine learning tools to recognize that. So it is getting more and more active.
Yeah, that's fascinating. That leads me into another one of my questions, which is actually more science fiction based, the theoretical, the Dyson spheres, because...
Yes, Dyson spheres are wonderful. There actually is a scientist that's looking for Dyson spheres at the Institute, which is pretty cool. So for those of you who haven't heard of Dyson spheres, there's a wonderful science fiction book. It was by an English author called Bob Shaw back in the 70s, called Orbitsville. It's not a very well-known story, but it actually is quite a good story about Dyson spheres. So check that one out. So the idea is that the more advanced a civilization gets, the more energy it's going to need. I mean, we see that already. And human civilization now is very, very energy hungry, and you need to produce a way to produce a lot of energy, that doesn't destroy your planet, basically. And solar energy is a good way of doing it. The trouble is you've got to build a lot of solar panels. So even if you do that, you can only get a certain amount of the energy from the sun. But supposing you could get all of the energy that the sun emits, how would you do that? Well, you'd actually build a sphere of solar panels surrounding the sun, which would be absolutely immense and engineeringly completely beyond what humanity can do, even into the distant future. In fact, generally building a solid sphere surrounding your star, that's called Dyson sphere, after a physicist, Freeman Dyson, came up with the idea, is not very stable. And so what you'd really need to do is instead of one solid object, you need to build a whole set of smaller objects in a sphere. And this is what's called a Dyson swarm. And that way you can actually capture the energy from the entire star and surrounding it. So this will be an incredibly advanced civilization that could do that. So how can you tell that this is out there? There's a couple of ways. And one way is the same way that you discover planets around other stars. Because as I said, if you've got a star and a planet moves in front of that star, it blocks a little bit of the light from that star. And so the star gets very, just very, very slightly dimmer. If you have one of these Dyson swarms where you have large solar panels, for want of a better description, the size of a planet going in front of the star, from our perspective, you would be able to monitor a star, and you would be able to see the dipping and the brightness of these stars because of these panels moving between us and the star. And that is a way that people are actively searching for Dyson spheres and Dyson swarms at the moment.
That's really cool.
And they may be out there. And the nice thing is that you're going to detect them from quite a distance away. But this is where machine learning comes into play. And if you see a dip in the brightness of a star, is it because of a planet? Is it because of a Dyson sphere? Is it because the star's naturally getting brighter and dimmer anyway? There's so much other stuff going on that, and you're analyzing, thousands of stars. That's where you get your machine learning playing.
Definitely. And I suppose it's a bit of time as well, because you have to watch it over a cycle to see, the timing on the results.
Yep. Absolutely. Yeah.
There are some candidates for these then, or something? I think I was reading something like that.
There was there were some potential candidates that was a discovery in a slightly different way. So most stars have a very characteristic temperature. You can have a look at what's called the spectrum of a star. Our sun has a spectrum, and you can tell that its temperature and everything. Now, if you had a Dyson sphere surrounding a star, or parts of a Dyson sphere, then the light from the star would hit this object, solar panels or whatever it's made of, and would heat it up, and that object would start to get hot. Which is not good. So you need that heat to evaporate into space. So you need to be cooling fans for it and everything, or whatever an advanced civilization would use to cool it off. But heat is infrared radiation, heat radiation. And so what you can do is you can study a star and you can look at the light coming off of it, and you see the visible light. That's fine from the star shining. But if you then detect this extra heat, this extra infrared light coming from a star, then that's not being produced by the star. That's being produced by something that's being heated up by the star. And so what you'd want to do is build a big infrared detector, or a telescope that detects infrared. And very nicely, we just launched one. It's called the James Webb Space Telescope, or JWST, which is an infrared telescope. It was not designed to find Dyson spheres, but it actually is very good at finding Dyson spheres, because it's looking for this extra heat coming from an object that's being heated up by a star. And so that is the best Dyson sphere detector you could possibly have. So who knows?
Oh, that's interesting. So it's kind of doing double duty, as in like taking the photos and then also doing that.
Yep, it's doing multiple duty. It was designed to look at distant galaxies, and it was designed before any planets around other stars had ever been discovered in the 90s. And suddenly they realized that this telescope they built to look at the distant universe is actually amazing at looking at planets. And then they realized, oh, it's amazing actually looking for Dyson spheres. So suddenly this telescope is one of the best sort of Seti tools out there, which is really cool. You never know what you're going to discover. That's the nice thing.
That is really cool. Yeah, exactly. You just don't know, do you? I suppose you just have to be open to everything. And I know Hans had a question, but I was just trying to add him. Hans, I think you have to accept when I think I send you an invite to speak, and then you accept it. But also, Simon, I know that you have written a book, which I think I hadn't actually realized till I read your bio, but it's called Touch the Invisible Sky. So I wonder if
so no, it's you know, the nice thing about the job here at the Seti is you get to do lots and lots of different things. And one opportunity I had was to work with a team actually out of Charleston, South Carolina, on a NASA program to develop materials for visually impaired students. And we put together a book about the multi-wavelength universe. So that means that you can look at a galaxy or you can look at a star in normal light that we can see, and things look a certain way. But visible light is just a very small part of what we call the electromagnetic spectrum. So there's infrared light that we've all heard of, you know, that's basically the glow of something warm. There's ultraviolet light, that the main way we detect it as humans is getting a sunburn, but it's given out by hot objects, including the sun, but you need a special telescope to detect it. There's X-rays, which is a type of light that actually is so powerful that, of course, it just goes through us, hence it's useful for illuminating our interiors. And then there are radio waves, radio light, which is great, as we talked about, for communicating, because it can travel long distances. But objects look very different in each one of these realms of light. And it gives astronomers a very good idea of what's going on, and how things work, how stars are made, what conditions they're like on planets, how the sun works, you know, and for space weather and solar flares and eclipses and so on. But of course, if you're visually impaired, you don't even get the visible component of that. And so what we wanted to do was to do a book where you could look and touch at the same time images of different objects in these different light realms. And we went with a team in Puerto Rico who was expert at this, to develop a Braille book that actually has images in it, but it also has tactile components to it. And so somebody who is sighted and non-sighted can read the book at the same time. It was a great project. I really enjoyed it.
That's a really that's a really great project. I think I told you I did some audio descriptions for visually impaired on 2 seasons of Doctor Who. So you know, I really enjoyed it because I was learning a lot about the show. But
what's very interesting actually is you know, for what you're doing, you know, for audio support and also visual support with tactile images that are used a lot now in museums. If ever you've gone along to even art galleries now have these tactile books, you can study the artwork there. Is actually, we found that the sighted people get much more information out of an image if it can be touched. And so the more senses you bring into play in studying something, the more comprehension you get. So even people who are sighted found the experience of being able to look at and touch an image gave them much more insight into what was going on, which is really neat.
That's really fascinating, actually. It's it's something I suppose that you just sort of learn as you as you go along in doing the work on it. But that's Emily. Did you have another question? Because I'm trying to get Hans, but he doesn't seem to.
Yeah, Simon, I think I heard you say that you haven't actually found any alien life, but maybe you can clarify that if maybe there's some signs or something you can share with the public.
The cool thing about, of course, is if you ask somebody who works at the Seti Institute, or have you discovered any aliens, and you say no, then obviously you're lying because you're covering it up. So no, we haven't discovered anything yet, or nothing we can tell you. But it's very interesting, the whole concept of finding, a signal, detecting that signal, because in the movies, of course, unless they're actually sort of coming down on your head, like in Independence Day, there's always seems to be this massive cover-up, like in the X-Files. But that's not how science works. And mainly it doesn't work because if our telescope, which is up in Northern California, makes a discovery, and we keep it a secret and don't tell anyone, then nobody will believe you. Why would they if they found out? So the first thing that you would do, what's the first thing you would do if you made a discovery? Well, the first thing you need to do is make sure that it's real. And to do that, you have to tell other people to look. It's like in the horror movies where you sort of you see Bigfoot out the back, and they say, look, there's Bigfoot sort of hiding around the corner, and everybody else looks and it's not there. Of course it's not there, because that's the tension of the film until it sort of attacks you in the end, and then you have to tell everybody that you made this detection, made this discovery, so that it can be independently verified, because you don't know if it was just your telescope not working properly. It may have been a computer glitch. It may have been just a satellite download, which is one of the big errors that comes in. So you need to have other people independently verify that it's real. And so the first thing you do is tell everyone. Now, in the old days, although it still exists, you would go through an organization called the Central Bureau of Astronomical Telegrams, which is a wonderful name. It sounds like something out of a steampunk movie, because who sends telegrams these days? But what it is, it's a central depository or clearinghouse of discoveries. And it could be discovery of a new planet, it could be a discovery of an exploding star, a supernova, and you report it out to this organization that happens to be in Cambridge, Massachusetts. And originally you'd send a telegram. And what they would then do is send a telegram to all of the other observatories to say, hey, look at this. Let's try and have a look at this object. Now, of course, it's all done by email. But I think these days, even that's not true. What you would actually do is you would have a WhatsApp group with telescopes around the world, and you'd send out a message, because then you can get effectively real-time observation, and you double check and get everyone to tell you. The other important thing is, of course, is you get a Nobel Prize if you make a discovery. And so you want to make sure that you tell everyone first. You don't want to wait for somebody else to make the announcement, because then they will get the Nobel Prize and you don't. So it's all ego.
Oh gosh.
So, scientists are real people too, whether we like it or not. So there was a one famous false alarm. It's called the wow signal. I don't know if people have heard of the wow signal, but it was an observation made back in the 1970s, and made by a telescope in Ohio, and it was this incredibly loud burst of energy, radio energy. And when it was discovered, and you can go onto Wikipedia and have a look at this, and of course back in the 70s it wasn't on a computer screen, it was on a paper printout, and the person who made the discovery ringed it and wrote wow exclamation mark on it, and it became known as the wow signal. And it's been put forward as the potential greatest possibility of a detection of an alien signal. The biggest problem is nobody else measured it, nobody else has found it, so nobody knows what it is.
Oh, that is wow.
Yes, yeah.
Literally. And I suppose you can't really, if things don't repeat, it's hard to verify, isn't it?
Yeah, it's you know, this analogy of something appearing out of the corner of your eye, and you look around and it's gone. And was it real or not? You know, was it a cat? Was it your imagination, or was it a UFO? You need this independent verification.
Yeah.
But the wow signal's famous. Actually, those of you like the Dandy Warhols, they did a great song called Seti versus the Wow Signal. It's good. It's a good listen.
So Hans sent me a question. He said,
Yes.
he said he looks forward to your book, and he's wondering if you'd read or seen the three-body problem. And he says that also mentions the wow signal.
Yes, indeed. It sort of comes up. It's sort of and it was mentioned, I think, in Elio, the latest Pixar movie. But I have read the first volume of the Three-Body Problem. It's a very interesting story in lots of different ways, about first contact, about whether we should be messaging aliens. Seti as a science is a very passive science. That is, we receive signals, we do not transmit signals, because transmission into space is quite controversial. I think unnecessarily so. You know, it's very easy to see that we are here without beaming something into space. So I think that's a bit silly that we're worried about that, but it is controversial. And of course that in the three-body problem, interestingly, even though we were warned not to write back, we did. Careful, you know, careful what you do, and the consequences of that. So it's a very, very good story. It's a lot of interestingly, says a lot about Chinese society, because the author was Chinese, as it does about alien civilizations. But the TV show was quite good as well. That was reset in Oxford, which was good.
Yes. Well, thank you so much. Emily, do you have any more questions before?
I'm just fascinated. This has been so interesting just to know what's out there and what's being done. And I'm so curious just in general, like now that the government kind of came out that there's UFOs, and I don't even know what they call them now, that, you know, maybe more people, now that more people think that it's real, like maybe it'll show up.
I think, you know, it's always been, I mean, it's a very easy sell, discovering aliens, you know, because everybody, wherever you are, eventually you get around the question is, are there aliens? Have they visited us? You know, do you believe in them? Do you think there's life on other worlds? It's something that is universal in us as humans to want to know this. And I think we all crave an answer. And you know, some of it we get from, you know, the sort of slightly more sort of dubious sources of the web and news media. But you know, people do see these things. And you know, I've given presentations where people have come up and, you know, told me that they've seen UFOs, and the answer is yes, they have. UFO stands for unidentified flying object. It was flying, it was an object, and it was unidentified. And so I'm very, very few people make this stuff up when they see something. The big problem then comes in, do you think it was a flying saucer? Do you think it was aliens? And the answer is probably not, but you can't prove that something didn't happen. And that's where science comes in. That's where you need something to be independently verified. If you photograph something, please get it in focus and not blurred. And you know, there are certain things criteria that you need to follow from a scientific point of view to actually verify something that is, you know, very, very odd. And you know, the odder it is, the more verification you need, basically. And certainly, you know, alien life is as strange and bizarre as you can get. And therefore you need a lot of proof if you really want to say, yes, I believe that it's true.
Definitely. Well, I'm sure the next few years are going to be very exciting with all of the, you know, technological developments and AI and everything that's going on.
Yeah. We're getting closer and closer. I mean, it's one of those things that it may not happen. You know, this is I don't want to ramble on about it, but you know, this SETI is a long-term. This is a generational quest. It's not something that can happen tomorrow, even though it might happen tomorrow. This is a science equivalent of building a cathedral. You know, this is something that you do as you lay the foundations for future generations. And we may not get an answer for a century, 2 centuries, but it might happen today. And that's what makes it very exciting and maybe a little bit frustrating. But it's not a rapid solution. It's something we work towards.
Definitely. Well, thank you so much. I'm sorry we had a few technical issues, but this has been
no, but technically it was me trying to figure out how to work. I was the technical issue.
No, it's okay. There's a lot of great information, and I think this stays on X so people can listen in future. And
okay.
Yeah, it's been brilliant, Simon. Thank you so much.
My pleasure, and it'd be lovely, you know, if you're happy to come back anytime and chat. If anything comes up, any discoveries or anything you'd like to talk about, I'd be very happy to join.
Oh, brilliant. I'd love that. And thank you everyone for joining.
Thank you for joining. Thank you, Sarah, for hosting.
Thanks.
See you next time.
See you next time.